De ervaringen van 1919 brengen Popper op een gedachte die de grondslag zal vormen van zijn latere werken. In plaats van onze theorieën bij hoog en bij laag te verdedigen, zouden wij beter het voorbeeld van Einstein kunnen volgen en onze theorieën zoveel mogelijk aan weerlegging moeten blootstellen. Vreemd genoeg zou het 15 jaar duren voordat Popper deze gedachte voor het eerst zou uitwerken en publiceren.
I had no idea that it was generally known. I felt that it was quite clear that the scientific attitude is the critical attitude. And it was also quite clear to me that a critical attitude is an attitude which tries to put the theory to a test. And to put it to a severe test means an attitude of trying to falsify one's own theory.
What made you publish it in the end?
I wrote it and published it really mainly because I foresaw Hitler's coming to Austria, and I've wanted to have something done which I might use for emigration from Austria. I was then a school teacher, and I felt I would have to emigrate, and in order to have something to fall back, I tried to publish the book. That was one of the main motives.
Logiek der Forschung, Poppers eerste boek, verschijnt in 1934. 2 jaar later emigreert hij. In 1938 vindt de Anschluss van Oostenrijk met Duitsland plaats. Tijdens de Tweede Wereldoorlog publiceert Popper The Open Society and Its Enemies, een felle aanval op dictatoriale tendensen in de ideeën van Plato, Hegel en Marx. Na de oorlog vestigt Popper zich in Engeland en in 1963 verschijnt een uitwerking van zijn ideeën over wetenschap onder de titel Conjectures and Refutations.
The situation of a scientist, that is to say a man who wants to find out something new about the world. The situation is, as I have sometimes said in my lectures, that of a black man who in a black room looks for a black hat which may not be there. That is roughly the situation. Now what can he do? That's all he can do. He can tentatively try for the black hat. Tentatively. That is more or less the situation of someone who looks for new knowledge, or for something, who wants to solve a problem which hasn't been solved. The only possibility is by trial and error. That is all, really. Trial and error, that is what I call, in the title of my book, Conjectures and Refutations. The conjectures are the trials, and the error corresponds to refutation. Now, the error is very important. I would say every time when he does find out that some of his conjectures have been wrong, that means really error, he does get some, he has got some result. He has got somewhere near the truth.
In a very roundabout way.
Yes, if you like, in a roundabout way. Have you a more direct way to offer?
Not yet, no.
It is the indirect way through which we can get knowledge. If we know where the truth is not, we do know some truth.
De Franse filosoof René Descartes, de grondlegger van het rationalisme, stelde dat wij via ons verstand in staat zijn kennis te verwerven die boven iedere twijfel verheven is. Hoewel Popper zich ook een rationalist noemt, ontkent hij dat het verstand ooit zekerheid kan garanderen. De Engelse filosoof Francis Bacon, grondlegger van het empirisme, meende dat wij op grond van waarnemingen tot zekere kennis kunnen komen. Ook deze stelling wijst Popper af.
Most people who criticize the negative method of trial and error, learning by mistakes and learning from our mistakes, believe there is another method, namely that we learn by observation. Many years ago in Vienna, in the Department of Physics, I did address a class of physicists who believed in this learning by observation method and said, "Now we'll start. Please observe and write down your observations." They said, of course, what should we observe? In other words, you can't observe without a problem. So the problem comes before observation. And the problem is always the question whether a certain theory is true or not. Now, this view of the matter says we shall often have to reject a theory which we have held for a time and come to a better theory. If you look at the history of astronomy, for example, you start, of course, with the view that you live on a flat Earth, an unmoving Earth. You go on from there to a heliocentric system, which assumes that the sun is unmovable and in the center of the universe, and so on. So it is essentially a history of rejection of false theories. Step by step, we do reject aspects of our theories and learn more. That is the way we learn. It is quite interesting. I have only a few days ago come across a passage in a 19th century book on the philosophy of science. And this passage shows that there was a problem. The problem was, what have the Greeks done wrong that they didn't find out what we now know, namely Newtonian mechanics, Newtonian astronomy, and so on? Why didn't the Greeks observe? Why did they not experiment? If they had observed and experimented, they would be where we are now. That is wrong. It takes time to get rid of your prejudices. It isn't that the Greeks, although being very clever and very gifted in poetry and so on, were a bit slow on the scientific side. They did extremely well. They did refute a few errors. What else could they do? What experiment and observations do is really helping us to get rid of prejudices, not helping us to build theories.